The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is Overhead and Underground Electric Safety. This topic is being presented by Marco Rossi from Amprobe, a Fluke corporation. Marco is the category manager for the Americas for Fluke portfolio products, previously in the thermography business unit. He's an electric engineer, level 2 certified thermographer, working for Fluke for 4 years. Before that, he was a marketing manager and oil and gas application engineer. Before Fluke, he was a sales manager for a distributor in South America. Expect today's presentation to last roughly 40 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Marco.
Thank you, Christina. Hello, everybody. We have a very nice agenda today. You're here for the Overhead and Underground Electrical Safety webinar from Amprobe. We are a Fluke corporation. We were acquired by Fluke almost 20 years ago. Let me go very quickly through the agenda. We have a nice agenda with focus on safety metrics, overhead electrical safety, and test and measurement. We're going to talk about risk and of overhead and underground electrical accidents. What are the current primary electrical safety guidelines in the USA? Why you guys should invest in a non-contact high voltage detector if you're dealing with high voltage outdoors. The second part, we're going to talk about underground electrical safety. Why is it important? And we'll talk about some specific scenarios. Why should you guys invest in an underground utilities locator? And how do they work? And what information do they provide you to make it worth a purchase? So let's kick with some interesting data that we extract from the Bureau of Labor and also the OSHA website. In the last 24 months, 132 accidents had happened when someone made contact to energized lines or conductors, whether underground or overhead. This means that the accidents were caused because whether the end user did not know that the lines were energized or they just did not have the right for the proper PPE. Another piece of information I want to share with you is that 31 people, according to OSHA, suffered accidents by making contact in any way with transformers. Again, similar scenario, whether they did not know they were energized or they did not have the right PPE, or they were not even following the right approach and protocols to the equipment. Similar situation we have seen also reported in OSHA with accidents when people touch or make contact with energized switchgears. And all these accidents involve arc flashes or electrocution by contact. I pull out other numbers. These are more dramatic numbers coming from Industrial Safety and Hygiene News. 30,000 arc flashes and incidents or accidents happened in the United States last year. 7,000 burn injuries and 400 fatalities, way more than the ones reported in OSHA. Another, I guess, less dramatic metric is that every 6 minutes, an underground utility is damaged because someone digs without the right information or without knowing the depth of the utility. Long story short, lack of information. So what causes these accidents, right? So we kind of like took the NFPA 70E info and also, again, the data reported by OSHA, and we split the causes in 6 buckets. The first one, it's racking a circuit breaker. Yes, we have seen cases of customers still struggling on de-energizing or even confirming that a breaker or a transformer is 100% de-energized when inserting or removing breakers. Accidents also still happen because users make contact with loose conductors. They are hot or energized. Amazing, but it's still happening, right? When opening or removing panels, there have been electrocution cases because fasteners are somehow making contact to the energized circuits. So again, this is a binary situation. Customers do not know if the circuit or the system is energized or de-energized. Also, some other accidents have happened because technicians try to cut specific segment of cables, believing that they're de-energized cables, and then by mistake, when cutting these conductors, they they make sure with another phase that it's energized. So another reason why that could cause electrocution or even an arc flash. And so go on, right? We have reported accidents because an user used contact test and measurement device incorrectly, and or just using test leads incorrectly. And also, they're just not careful operating test and measurement device in an energized circuit, right? That's why it's always important when you buy a multimeter, a clamp meter, an insulation tester, or an insulation meter to not only be aware of your whole system, but also read the manual, right? Using this type of equipment, even if they're category 3, category 4, certified 1000 volts, 600 volts, it's always very important to read the user manuals if you're not familiarized with the equipment. And yeah, you guys might guess that the common denominator in these accidents is that the users did not know that the equipment was energized or de-energized. It wasn't a safe condition. All the 6 different buckets that we characterized before, common denominator is the environment or the equipment energized or de-energized. This brings the enforcement element on the table, right? To the safety teams, the compliance, safety, tiger groups, and all the major companies. And safety departments should have internal documentation, protocol, and processes that will provide clear guidelines to their employees when manipulating electric energized equipment or electrical equipment. These documents or protocol, they have very large scopes, right? We have the NFPA 70 adopted by major safety teams. There are also technical information related to understanding accident causes, right? So they experiment accidents, and based on what failed, it's documented in their protocol. How energy behaves and what are the safety boundaries that the user should maintain to avoid these accidents, right? So more of an empiric approach. In our case for electrical safety, the OSHA 1910 and 1926 subparts from the code 29 are key standards that contain safety guidelines when operating transmission and distribution equipment. Now, another thing I want to mention is that the 1926 provides even electrical safety regulations and norms exclusively for construction environments. If you look at OSHA 29 and you go to 1926 subpart V, you're going to see that this is specific electrical guidelines, safety guidelines for construction environments. And we'll talk more about this later with the underground utilities locator. So I would like to spend also some time here talking about the standard 1926, the one that I mentioned below, from chapter 29. The standard provides safety and health regulation in construction sites, specifically for overhead line and underground electrical installation. So the information you're looking at the left side of the deck, it's 964 paragraphs. And this paragraph from OSHA stipulates that for overhead electrical systems that customers must be aware of the minimum approach distances when dealing with the lines. It could be overhead insulators, conductor, transformers, any form of high voltage equipment in the surface. The norm enforces, or actually not enforces, recommend customers to know what are the safety distances that they should take in order to avoid electrocution on potential arc flash. The paragraph also mentions that customers should acknowledge safety distance. Not only read them and have it documented, but be self-aware what are the safety distance, right? They should know it top of their head, how they should be positioned in terms of line of sight distance, depending on the voltage that the line is containing. We'll talk more about this on the next slide because it involves the usage of a non-contact voltage detector. It plays a critical role for this specific case. The 965 paragraphs provide less clear but basic guidelines related to underground electrical conductor safety or electrical installation safety guidelines underground. As they are contained into a construction and safety guidelines, as I mentioned before, the 1926 it's directed to construction environments. Remember that in open construction sites, excavations are always critical. Right? I would say probably half of the construction sites, they have one way or another excavation projects or manual or heavy tractor excavation elements. And unfortunately, the accidents happen when users make contact with energized circuits when excavating, whether they're using a shovel, they're using a tractor. And we're going to talk more about this on the section related to underground electrical safety. So right now, we're going to focus on overhead electrical safety, right? Where I want to spend more time is on the definitions here, right? On what are the common knowledge gaps that are associated with the OSHA standards that I presented before. The definitions of approach distance, the concept of approaching distance when dealing with electrical safety, it's super critical. We always encourage customers, look as a company, to manage the vocabulary properly. When dealing with safety distances, we want our customers to comprehend what are the requirements and consequences when being at different safety distances, right? So we'll start explaining what is the R-flash boundary. This is a clear definition. It's contained also on OSHA 1920 regulations related to safety distances overhead. R-flash boundary, we can call it also restricted approach boundary. It changes depending on what is the R-flash hazard, right? Sometimes the boundary is furthest based on the exposed equipment, right? And we can call this the safest zone right now. Typically, customers are required not to pass the R-flash boundary unless they have PPE and test and measurement equipment that fulfills the categories of voltage protection. They got closer, right? Now, the more they got closer, they got to the limited approach boundary, which is you move towards to the energized and exposed equipment, and you'll find this boundary, right? It is possible at this point that you are exposed to a shock hazard, right? So accidents probabilities will increase dramatically based with arc flashes if you get close to this area. And at this point, experienced user, they need to wear PPE, and they should be qualified workers. Qualified workers mean that they know what are the safe distances defined by the company and by OSHA. Number two, they have the right PPE. Number three, they know how to operate, whether contact voltage or current detectors or test and measurement tools or non-contact tools. And it is highly recommended that non-experienced users or technicians should not get to the limited approach boundary, even if they have PPE gear. And then the last one, which is like the hot zone, is the restricted base or the restricted boundary, right? And at this point, this area is close to it's the closest area to the live exposed equipment. And not only you need to be a qualified worker and have the PPE, but you need to have the proper training or how to manage the exposed equipment, right? And if you need to perform work on an energized equipment in a restricted space, you might also need to have a work permit and documentation if you're dealing with a public company. So, long story short, here is where do high voltage NCVs or non-contact voltage detectors play a role here? So, depending on the amount of voltage of the line, all NCVs detectors provide sensitivity tables that can be associated with the safety distances, right? So if you buy, let's say, an Amprobe TIC 300 NCV that goes from 30 volts to 122 kV range of detection of AC voltage, you will have in the user's manual a table of sensitivity. And if you plan to work on an overhead substation dealing with 34.5 or 19.9 kV and you're using one of these equipments, well, you might know that the equipment will react or will detect voltage at a distance, at a minimum distance of between 9.4 and less than 13 feet, right? If you're in industrial environments where you must deal with lower voltages like 2.4 or 1 kV, you can associate that amount of voltage to the detection distance or sensitivity distance that the equipment has. And then if you're speccing this equipment in your protocols as a spec tool, you can associate these sensitivity distances and voltages to your safety electrical manual. And exactly that's one benefit of adopting this technology, right? Companies enforces you to stay the farthest as possible from the equipment, right? Another thing is that the NCVs as a technology, they're typically between 10 to 15 inches tools, but they come with adaptable hot sticks, right? Or they come with adapters that they can have a hot stick attached. So if you want to stay the farthest possible from the detection distance, even if you're in the thresholds defined by the sensitivity table, you can just use a hot stick and stay way, way far from the hot areas. So what are the NCVs are pretty straightforward tools, right? They're very, very intuitive, but we still see some customers that do and do not know what these tools do, right? So the straightforward benefit of this equipment, of a high voltage non-contact detector, is that they just don't make contact to the hot line, right? So there are other voltage detectors in the market for high voltage that they do make contact. Some of them provide just a yes or no voltage detection flag or light. Other they provide the real measurement or the actual measurement of the voltage in that line. But regardless, you need to make contact with that equipment to the line. And there's always a hesitation from end users to take that approach because they're just not comfortable to make contact with anything that it's above 220 volts or going above 1 kV, right? So that's one of the main benefits, right, of the non-contact high voltage detectors. You do not make contact to the hot line, right? Now, unfortunately, they don't work as most non-contact technologies when the cables are shielded or they have some kind of jacket that isolates or entraps the electromagnetic field, right? So if you want to, let's say, to detect voltage on a high voltage energized cable that it's shielded, you need to go straight to the terminal, to the naked terminal where you can see the conductor to detect or not voltage. Well, this is pretty intuitive too. The non-voltage detectors do not work with DC voltage. They only work with AC voltage. And I think I mentioned this before. They don't indicate voltage, shielded cables, and ground enclosures. And another thing, and this is kind of like related with this conversation, the non-contact voltage detectors, they might not work effectively with underground cables because the main reason is that the soil or anything that it's concrete or anything that it's standing above the underground cable, that might block the expansion or the propagation of the electromagnetic field. Hence the reason why you're never going to see, or you're very, 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 very few situations where you will see someone using an NCV equipment to detect voltage on an underground cable. It's just the equipment is not powerful enough to detect the signal, and the layer that it's above the cable, it's blocking the electromagnetic field. And that's the reason why we have also underground utility locators that we'll talk about that later. There's another element that it should be considered when you're purchasing an NCV, a non-contact voltage detector, and this is tied back to safety, right? Safety standards, safety compliance, safety testing, safety certification. Some brands in the market, they offer detectors that have gone through intrinsic safety evaluations. So we have seen in Europe some brands that they comply with ATEX certification, intrinsic safety certification, but this guideline, it's not traceable to NFPA USA, or it's not recognized with OSHA. And here in the States, I believe we haven't seen a non-contact voltage detector that it's compliant with an intrinsic safe regulation, with the exception of the Amprobe TIC 300. Our TIC 300, the product that we're presenting right now in the next slide, it's a non-contact voltage detector that it has been MSHA certified as an intrinsically safe equipment. MSHA, it's basically the homonymous of OSHA, but for the mining industry. And what does that mean? What is an MSHA intrinsic equipment or intrinsically safe certified equipment? Is an equipment that has been going through a set of 9 or 10, I believe, different tests: spark ignition, limitation resistant test, temperature, small components, ignition testing, dielectric. A lot of high stress testing of the electronics of the tooling case to make sure this equipment is safe to use. Number one, on high dense environments. Dense, I mean with humidity, dust level, high dust levels, also water levels, sparkling levels of water to the equipment, but also that have a high compression of energy generated, static energy generated by the equipment, right? And this is very useful when you're in explosive environments, very similar to the APEX regulation. But this provides that safety element that makes our customers and technicians in general very comfortable using this equipment. So Fluke has a one with the brand Amprobe. It's called the TIC 300 Pro. Is a, as I mentioned before, is a high voltage non-contact detector, and the range goes from 300 volts all the way to 1500 volts AC for the low range setting, and it has a high range setting that goes from 1500 volts AC all the way to 122 kV. There are in the markets other brands also that go all the way to 200 kV. Now, what makes this product very valuable, it's the MSHA certification, the Intrinsically Safety certification under the MSHA standard, which is a key value. I believe it's a sales value for our customers right now, regardless their vertical or their market, right? We have seen customers from oil and gas, from chemical manufacturing, even from mining adopting this product because it's compliant with that regulation. Another thing that this is a product that has been tested at QC, at quality control phase, with a drop test of 6 feet or 1.8 meters. So if you have more questions around this product related to pricing or more technical specs or applications, feel free to contact your Transcat inside sales team, and they'll be happy to provide more. Now let's switch gears and let's go to underground electrical safety. So we talk about, okay, what are the main issues that we have in overhead electrical safety that are recognized by the federal regulations, whether OSHA or traceable to NFPA. But now let's spend some time also with underground electrical safety. And this is more of a graphical guide, but slide. But underground electrical accidents that leave human losses are typically caused by making contact to an energized circuit or conductor. It's always the same thing. Excavation projects, they touch a energized line. The energized line acts as a conductor through whether it's the tractor or the shovel, and there are accidents happening that typically report with second degree or third degree burns or human losses. I had a couple of videos here. For the sake of time, I want to show this one only, the one in the bottom left of my screen. This is a perfect example of an accident that happens when there's an excavation project, and whether it hasn't been validated that the circuit was inactive or de-energized, or they just dig on the wrong depth. And you just saw what happened, right? The tractor made contact to an energized line, create a sparkle. Fortunately, the tractor is grounded or is isolating the operator, but still, you can clearly see that it's a dramatic video, right? Think about if there was someone in a range of between 5 or 6, 7 to 10 feet from that area, and it could be affected by that issue. There's another video here. I'm not going to spend too much time on it, but because it's a long video. But for the sake of letting you guys know, it's a video that shows what are the consequences of excavating other utilities other than electrical. This is the case for electrical gas utilities. And what happened is that it touches the pipe 120 yards away from a house. The tension that it's made by the tractor to the pipe creates a crack on a base on the pipe at the basement of a house, and gas leak touches the sparkle of the water heater, and nice explosion. I can send you the links later about this video. But long story short, again, what I'm trying to leave with this slide is that all the issues that are happening underground, specifically electrical underground safety issues, involve excavation and making contact to energized circuits. So why these accidents happen, right? So we know that they happen because the common denominator, as I mentioned, it's excavation. People excavate whether with tractors, with pickaxes, or with shovels, right? But let's try to bucket them by cause, right? So the first one, what we have noticed is that some operators and users with tractors or shovels, they kind of like know the depth, but they don't have information that validates the depth of the utility. They know that there is one. They believe that it should be a one specific depth because they experienced a previous excavation, or they just don't know it, right? It's a common sense situation, right? That said, I've seen contractor crews, the majority of contractor crews, they're highly compliant and responsible. They do try to keep themselves documented with the circuit plans. But yes, we have seen such scenarios or situations where a contractor, it's running an excavation project, they bring a tractor, they start digging, they believe the wire or the circuit is located at X amount of depth, and it turned out that it's way closer to the surface than they thought. And they didn't even validate it they didn't took all the preventive measures that will de-energize the circuitry. The second one, which is pretty interesting, it's overlapping of electrical wires. So we have seen that, yeah, that is critical, but still accidents happen because some customers, they just don't know what are the directions of the circuits, right? Or they have old plans where they're reporting also one circuit at a specific depth, but they don't see other circuits at deeper locations. But then they start digging, and they realize that by avoiding touching one, they touch another one, which was higher at a higher depth. And this is related also to the third point, which is old circuit designs. We have seen so many customers that they made contact with energized circuits because they have old plans. Like the plans are 20, 25, 30 years old. They didn't validate them. They were never updated. And because of environmental situations like soil moving, or maybe there was an extension done by another contractor, the depth doesn't match with the plan, and they hit the utility, right? And then the fourth one, which is more of a there's a less human impact here, more of a operational impact, is ground faults to the degradation of the insulation. And where do we see an issue here in safety, right? When there's a ground fault or a cable degradation issue, that can create some stack potential issues to people that are around the area. I also want to spend some time here talking about ground faults, just for the sake of economic analysis of how bad they are, less of a safety issue, but safety issues are definitely catastrophic, right? But ground faults definitely become an operational issue, because when you have a ground fault or a cable fault, you have a non-operational circuit, right? And again, you need to start digging. You need to find where's the location of that area of the cable that it's making short, or it's just had a deteriorated insulation and whether patch it or replace it. Regardless, that brings a lot of money involved by bringing the crew, shutting down the circuit, or having the circuit down already and replacing whether it's that specific mile, that specific segment, or the entire distance of the cable. One thing also important is that we have seen that the majority of cable faults that are happening and where our users are buying our equipment to find the faulty cables, degradation of the insulation majority of the time happens because of conditions of the soil combined with the quality of the cable. So where there's a high humidity coefficient, relative humidity coefficient on the soil, combined with high acidity, that's where we see more degradation on the cable insulator. And also we have seen that some certain types of cables, they fail. And we believe that's also related to the quality of the insulator of the cable. So again, type of soil, acidity of the soil, amount of humidity retained by the soil, also combined with the quality of the cable. Those are the main reasons why we have seen cable faults, hence our customers trying to detect where the fault it's located. So now we mentioned some of these scenarios around the 4 different safety issues that we might see with underground cables. Question now is, why do we need an underground locator, right? I mean, 4 different issues, but what is the practical purpose of an underground locator? An underground locator, number one, it can search on an area from the surface to locate the buried lines. This is intuitive, right? But also, besides locating the wire or the cable and detect or estimate the direction, it can also measure the depth from the surface, the depth of the cable. So that's super, super important when we are estimating depth of a utility and compare that with the plans that we have. Remember that many of the issues excavating are driven by very old plans. So it's always good to not only have the plan, but also contrast or compare the depth that it's on the plan versus what the locator is telling you. Locators can also find faults, right? Underground utility locators, they come with special accessories called A-frame that they allow the end users to detect what are the segments or the areas of the cable that present faults. And we'll talk more about that when we enter into the product details. Also can pinpoint the position of the joints, and this is more of a less of a electrical safety benefit and more of a utilities in general. It can pinpoint joints of metallic, whether it's water or gas pipes. The equipment is portable. You're going to see a picture later of how an underground locator looks like, and it's portable. It's easy to transport. It's easy to handle also. It's very maneuverable. It's ergonomic. And the technique works primarily in all soil conditions, right? It's more of an art for sure. There's a component of experience on using an underground utilities locator, but between the experience and how to manage the equipment, how to set also the expectations on when to use it, it works literally in all conditions. And there's a last component that this is super critical compared to other technologies, the electromagnetic underground utilities locators compared to the ones based on laser or ultrasonic. They're low cost. They're not as expensive as a ultrasonic underground detector or a radar-based underground detector. These are low-cost equipment, typically below the $8,000 or $7,000 price point. How do they work? There are 2 components in the underground locator. The first component, or the 2 major components. The first component is the receiver that looks like a vertical stick, similar to the metal detectors. And with the receiver, if the circuit that we want to detect, locate, detect, and measure the depth, it's energized, the receiver will do all the work just by perceiving the AC signal voltage coming from the conductor. It can estimate location and directions. And as I mentioned before, it's a very ergonomic tool. Doesn't weigh more than 3 to 4 pounds typically. Some products they weigh even less. And it provides visual interfaces and sonic interfaces to tell the user where the cable is located based on the sensitivity of the signal, what is the depth of the cable, whether it's feet or meters. And all this happens by sensing the electromagnetic field of the AC voltage flowing through the conductor. The receiver has a sensor. The sensor perceives the electromagnetic field lines, and by that and a combination of firmware analysis, it provides to the user what is the location based on the sensitivity to the signal, what is the direction, and what is the depth of the cable. Now, in scenarios where the underground cable is not carrying any type of current, or it's carrying DC current, which is not detectable by the receiver, we need to find a way to inject a signal that can be perceived by the remote unit or the receiver. And that's where the transmitter comes to play, right? The transmitter, what it does is that inject a special signal to the circuit that it's able to be detected by the receiver. These are signals that go in most of the brands between 8 kilohertz and 48 kilohertz. They have long propagation properties, and they allow the transmitter to perceive the signal even along distances where the transmitter is positioned. So this is basically an underground utilities locator or an underground cable locator. This is a Fluke Amprobe branded locator, and if you also see some other competitors, they're pretty much homogeneous and all the accessories and main units provided, right? There's always a receiver, which is a vertical equipment, looks like a metal detector stick, and it also has an LCD screen that provides all the information: the depth, the sensitivity of the signal, the sensitivity joystick. It also had the antennas, which are the small gray flecks that you can see in the middle and the lower part of the receiver. Those are the sensors that can perceive the electromagnetic field. There's also a transmitter, which typically looks like I always like to call it like a lunchbox. It's portable, doesn't weigh more than 3.5 to 4 pounds. And this is the equipment that generates the special signal that can be detected by the receiver in case the cables do not carry the AC current. And then a bunch of accessories, right? Accessories that are related to transporting the equipment, the carrying bags for the receiver and the transmitter, but also accessories that are related to the different type of detection modes. There's a signal clamp that is used for a specific detection mode. There's a couple of test leads that are specific for another detection mode. And we're going to talk about that later. It comes with batteries, ground rods, and typically fuses, right? This configuration is very generic. Now, that said, I mentioned two different modes, right? I mentioned active mode, or modes where you use the receiver and when current it's already flowing on the circuit. And we call that type of method or signals passive signals. Passive because the electricity is generated passively by a third party, whether it's a utility or whether it's an industrial plant, right? They're already injecting voltage, active nominal voltage at 50 or 60 hertz, right? And this is the most popular method right now that it's used for power utility companies, distribution technicians that want to see where the cable is located and what is the depth, and the lines are already carrying voltage, right? And also, as I mentioned before, other companies, oil and gas, process manufacturing, even telecommunications companies, that they want to detect where the wire is and they know that the circuit is already energized with AC. There is another mode that I'll explain more in detail later if you're dealing with special situations where you cannot inject a signal with the transmitter, and also the signal doesn't come with it's not energized with AC nominal voltage. You can put it in radio frequency mode, which is it's a reflective mode that I'll explain later. but it's a great option if you want to detect not only cables, but also other utilities that are not electrical. And very, very convenient, because what it does, it detects the spectrum, the radio spectrum radio spectrum waves reflected by the conductors, right? So anything that is in the radius, radio station, radio tower, cell tower for cellular lines, they are generating radio frequency waves. These waves are bounced or are reflected by the conductor, and the receiver can detect those reflections if it's put on radio frequency mode. And then there's active signals, which is the detection mode that it's used when the transmitter is needed. And when do we need a transmitter? When we don't have any power injected on the circuit, or we have only DC. There are three different ways to use active signals: by direct connection, and I'll explain that later, by clamp, and by induction. So three ways to inject a signal with an underground locator to a electric circuit. I want to spend very, very few minutes talking about a passive mode, and then we're going to jump into active mode. We have 2 minutes left, so I want to make this very quickly, but also have you guys remember. Passive mode, as I mentioned before, you use only the receiver. You don't need to use the transmitter, but you must have AC power flowing into the circuit, right? So it's very good when you know that you have energized circuits. Very, very popular when if you're a utility technician and you know that the underground cable is carrying AC current, right? In parallel, if you don't have AC power running and you cannot connect the transmitter, you can still use radio frequency. So two different modes that you have in passive mode without the need of the transmitter that can allow you to detect the wire and estimate the depth. So location, direction, and depth. Now, if you want more accuracy, or you're in a situation where you're having a lot of noise in radio frequency and you're not having AC power carried by the utility or by the cable, you need to use a transmitter. You need to inject a signal, whether it's an 8 kilohertz signal, 33 kilohertz signal, 45 kilohertz signal. That's the purpose of the transmitter. What are the three different modes of a transmitter? Very, very straightforward. You can use the transmitter in induction mode just by placing the transmitter on the floor, and it will act as a beacon and inject the signal underground. The signal will be captured by the conductor and it will be propagated as an 8 kilohertz signal. You can also use induction mode if you want to make sure you stay injecting the signal on a specific wire, on a specific circuitry. So just by using the clamp, you connect it to the transmitter, and if you have access to the cable of the circuit, whether at a panel or a cabinet where you can have access to the cable, you just connect the signal to the cable, go straight to the transmitter, and the transmitter induces the signal through the clamp to the cable. And the most accurate mode, and this is the mode that is the most popular one with underground locators historically over the last 20 years, is direct connection. You take the transmitter, you connect the test leads, and then the test leads go into an open conductor axis, and that will generate directly the signal to the conductor. And this is very popular, but it has been slowly being replaced by induction mode, because induction mode, you don't need to do any connection directly to the circuit, but it has some benefits, right? I want to spend maybe 30 seconds on this. Remember that the underground locator has many modes, passive and active modes, but they all have their pros and their cons. Typically, the pros and cons are related to the structure of the circuit. If you have one circuit or many circuits that are overlapping, if you have a lot of noise coming from radio frequency, if you have a lot of noise also coming from other DC signals, there are a similar frequency. So depending on that, you have many, many modes to choose, right? And that's where the art component comes, right? It's a matter of evaluating properly the environment, observing the clues, observing what are the setup of the circuit, see if there are, compare that with your plans, and that proceed to use whether the locator in passive or active mode, and within that, what are the modes that you want to use with passive or active. It's an induction, signal clamp, direct connection, all depending on the system configuration. With that, 44 minutes past 11, I would like to thank you guys for attending to this webinar, and I'm open to any questions.
Okay, thank you, Marco. That concludes the presentation portion of the webinar. We'll now move on to any questions and answers. Just as a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. Let's move on to the first question. Discuss two major causes of overhead underground incidents and reasons.
Yeah, so as mentioned before, one of the first underground issues is the lack of knowledge or using old plans, right? So not being 100% sure what is the depth of the underground cable, or using wrong information, such as an old plan that has old information related to the depth.
Okay, next question. What does OSHA 1920-269 mean with electric safety distances?
Yeah, so OSHA 1960, they define basically what are the guidelines of electrical safety overhead. So I think the main thing that needs to be remembered with that OSHA standard is that customers need to know what are the safety approach distances to an open hot circuit or open hot exposed high voltage equipment. And secondly, they need to be self-aware of what are those distances. So not only had it documented in their internal protocols, but also make sure that they know what are those safety distances based on the voltages carried by the exposed equipment.
Okay, next question. Why is MSHA intrinsically safe certification important on an electrical detection equipment?
Well, there is the safety, I call it a safety quality brand, right? It provides some peace of mind to our customers in dealing with high explosive environments, underground, dusty areas. So it's a peace of mind certification that provides safety to our customers. And within that, our customers know that spark ignition tests have been done to the equipment, stress spark ignition tests, temperature tests in a specific temperature ranges, dielectric testing, drop testing, flash current testing. All these are stress tests that allow the equipment to be operating safely at explosive environments, corrosive environments, or dusty environments too.
Can you name at least two factors, elements that will trigger underground cable faults?
Yeah, so one is the acidity of the soil that damages considerably the insulator of the cable. The insulation layer or jacket, it's extremely damaged by the acidity of the soil. That's one. The second one, I will say, it's the quality of the cable. That's another element that plays a role here. And also there's a component of humidity of the soil, but that's related also with the acidity. First part of the question the answer that I gave.
All right, that concludes for today. If you have any further questions or would like to find more about Transcat's product and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. Thank you for joining us today. We hope you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Marco, and I hope everyone has a great day.
Thank you. Have a good day, afternoon.
Bye-bye, everyone.